Welcome to a new video of this playlist. After learning in our last video how we can create a class, different types of constructor, and lastly, how we can construct our objects from that class, it's time to learn about new aspect related to classes. And today's aspect is going to be about inheritance. So inheritance is just a programming concept that lets a class acquires the same members of another class. Members such as the attributes and functions, for instance. So say, for example, we have a class called parent, and this parent class can have multiple attributes, for example, and some functions, like the family name, for example, the dwelling place, and maybe a function called does a job. Great. And whenever we want to create a class related to this parent, we can extend these three members of the class to be put within our new class. So say, for example, we have a class called child, and whenever we create this child class, we don't have to write these three from scratch. We can extend the parent class, and the members can automatically be within our child class. And you can see this is very useful because it increases the code reusability, as we write the code once and we used it multiple times in our parent, child class, and maybe we have other child classes as well. So the child class here surely have the same family name, the same dwelling place, and he does a job. It doesn't matter if he does the same job as the parent. Maybe he has another job, for instance. So for that, we're going to start with an example. As you may know, we have different kinds of developers. We have backend developers, we have front-end developers, we have Kotlin developers, Java developers, iOS, Android, just a lot of kinds of developers. But eventually, they're all considered to be some kind of a developer. For that, we are going to make a parent class or a superclass called developer, and then we're going to make child classes or subclasses that have the same members as that developer class, and these child classes are going to be specialized in some field, for example, Android developer, iOS developer, and so on and so forth. Now let's start creating our parent class. So it's going to be called developer. It's a class, and now it's time to add the members of this class, like the attributes and the functions. So I'm going to start to open the constructor and add the attributes here. Now, every developer at least must know one language. So we're going to have here a list of languages. So val languages is list of strings, and also every developer has some tools that he uses or she uses to write code in. So tools, just a list of string, and lastly let's have something like drinks caffeine, as just type boolean, true or false. If you're a developer and you don't drink caffeine, it's fine, it doesn't have to be that way. I would like to have this here because I would like to have different data types within the constructor. Now let's add what this developer can do. So every developer can code, so fun code, println coding, and let's have fun fixing bugs. So every developer should fix his bugs or his code bugs. So fix bug, um, fixing bugs, and lastly every developer should help other devs or other developers, so help devs. And now we are going to have here helping devs. Great, so our parent class is ready here. Now it's time to make a subclass or a child class of our parent class here. So for that, I'm going to make a new class called Android developer, for example. It's a class. Let's have them within in the same view here. So this is our developer class and this is our Android class. And now the way to extend these properties here or these members here is with the colon. So the colon stands for extends, or extend, and now you add the class name, so developer here, and you open the class constructor. But notice here we have some error because every class that you wish to make it a parent class of another class, like this child class here, and you wish to make the developer a parent of the child class here, you have to annotate it or tag it with the open keyword. And the open keyword here makes this class extendable. Great. The next thing which I want to do is just move this to the right to have some space. We still can see it. And if you see the constructor of the developer class after extending the Android developer, it requires us, if you press Ctrl P, it requires us to enter these values here. So we have multiple ways to do that. We first gonna enter them statically, so it's gonna be static values. So here, list of languages. So Java, and Kotlin. So for Android development, you need to know at least Java or Kotlin. And for example, the tools, so list of, again, we use Android Studio for Android development. In the past, we used to use Eclipse, and the for example, emulator to test your apps, emulator, or a physical device. And lastly, the drinks caffeine may be true for the Android developer here. And now you passed the values to the parent class, and now this Android developer is related or a child of the developer class. That's great. Now let's make an instance of our Android developer class here and try it out. So go back to our main function. Let's just get this back here. Yeah, get back to our main function and make an instance of our Android developer class. So val Android dev is equal to Android developer. And here we don't have to enter anything for the constructor as we don't have a constructor for our Android developer class. Great. Now let's just print the properties that we set within the class, like Android dev dot languages, Android devs tools, Android devs drinks caffeine, and finally let's try the functions. So we see here within our Android developer class we don't have any functions, but we extend the developer class, so we are supposed to have access to these functions right here: the code, fixing bug, and helping devs. So let's try to access them. Android dev dot code. See, we have the code, fix bugs, help devs, and let's run the program to see the output. And here comes the output. So languages, Java and Kotlin, tools, these three tools here, drinks, true, and the code, fixing bug, helping devs are printed here. Even though we don't have the functions here, they have been inherited to our child class, which is the Android, and now we can access them within our code, just like here. That's great. So say for example, you want to extend the class, you want to even to re-implement the functions within the parent class. So how can you do this? Well, if you want to do this, you have to annotate or have a modifier before the func keyword here. And this modifier is called the open modifier, just like the class here. So open function, open function, open function. And the open keyword here allows you to re-implement the functions if you want to. So if you go to the Android developer class here and we press Ctrl O, we can re-implement these three functions. So I'm just going to select them all with shift and click to the last one and hit enter. Now we see that they have been overridden to our file here, and override means that these functions are coming from a parent class that the current class extends, which is the developer class. So this is the override modifier. Now if we leave the code like this, we see that we have super keyword here, which is just new. As you can see, if we just highlight the super keyword, it refers to the superclass, which is the developer class here. And the super.code refers to the function within the superclass. So if we leave the code like this, it will call the implementation of the superclass here. The super.code will call the code function within our superclass, which is the parent class or the developer class. And similarly for fix bugs and helping devs. So if you leave it like that, we'll have the same output as before, this one here, but we want to re-implement the functions. So for that, we're gonna just delete the super code here, and we print coding in Android. Similarly, in the fixing or fix bug, fixing in Android, and lastly, helping in Android. Now let's just leave everything as it is in the main function and run the program. We would see that the output differs from the last output. So coding in Android, fixing Android, and helping in Android. Now we don't want to have static values, or we don't want to pass the values to the parent class within the same class. We want to pass them when we create an object of the Android developer class here. So for that, I'm going to have constructor for our Android developer class, and it's gonna have the same attributes as the parent, the languages, tools, drinks, caffeine. So I'm gonna have languages. I'm just gonna copy them over because they're just gonna be the same. And then instead of passing them here, I'm gonna copy them as well. Let's have Ctrl X. And instead of passing the static values, we want to pass the languages, tools, drinks, caffeine. And now, whenever we go to our Android developer, we would see that it requires us to enter some values. So we're going to have the same values as we have them in our class. And if we run the program, we would have the same result. That's cool. Now, whenever you extend a class from a parent class, the child class will act as if it was a parent class. So it will have the same properties, the same actions or functions, and it will just act as if it was a parent class. So if you go to the main activity now and check the type of our variable here under def by pressing Ctrl Q, you would find that it's of type Android developer. And if you specify the type explicitly with the colon and say developer, it will work, as Android developer is just a child of the developer class. So Android developer will act as if it was a developer class. And now here we have languages without, or we have these attributes here without the val keyword. And you can notice that if we add the val keyword here, we would have an error. And this error is just same as the error when you have multiple variables that have the same name, like val name equal to some string and val name equal to some string. It says the conflicting declaration, so you cannot have the same variable with the same name, so you gotta change the name. So this error here is the same as the error what we have here. So as long as we extend from developer class, Android developer here will act as if it was a developer class. So we have conflict declaration for these three attributes. So there are a couple of solutions for this one here. You can just have them as before without the val keyword, though they will not point to the same variables or the same attributes. But if you would like them to point to the same attribute as the parent here, then you have to add the override modifier, just like the functions here. And the last thing to do is to annotate the three variables here with the open keyword as well. So open keyword, and now you're good to go. But that's not it for inheritance. Child classes can also have their own attributes or functionality that are only dependent on the child class here. That doesn't have to have any connection with the parent class. So for instance, I'm going to make two new properties that represent the number of apps that were written in Kotlin and apps that were written in Java. So val Kotlin projects, projects, if type int. Another one for the Java projects, type int, as well as a dependent functionality. So I'm going to make a function that sees if the Kotlin project is greater than the Java project. So fun does Kotlin projects outweighs Java's, and it's just gonna return Kotlin projects greater than Java projects. Did I name it Java? Yeah, it was with the capital Java projects here. And if we go to the main function, we can call it here. So println Android dev does Java, and see we don't have access to that because we explicitly set the type of our Android dev to be a developer, and within our developer class we don't have this function here. So for that, let's just delete the type, and now we can access the function here. So if we run the program, we still have an error. Yeah, because we have to add the other properties that we added to the class, the Java Android projects like 10, 15, and the Java projects 10. And let's run the program, and here comes the result. And here comes the output. Does Kotlin projects outweigh Java's? And this is true. So far, we have been only making a child class. So let's make another child class of this parent class here. So I'm going to make a new child class called iOS developer, and our iOS developer, let's put this here, and our iOS developer is going to extend the developer class. So extend developer class, and here we have to pass the values. Before that, let's add a constructor to our developer class. And let's just type override, and it will just pop up here like the languages, comma, override tools, override the drinks caffeine, and then we pass them to our guy here, to the developer class. Press Ctrl space to have this shortcut here, choose the second one, and now our class is ready. You could override these functions if you want to add custom functionality, or you just can leave them as they are. Whenever you call them, when you make a new object, they are going to be implemented as they are implemented here in the parent class. So now let's make a new object of our let's make a new object of our this is yeah let's make a new object of our Android or iOS developer. So val iOS dev is equal to iOS developer, and here it takes languages, so list of Objective-C, so you can Objective-C, you can code in Objective-C to make an Android or to make an iOS app, or Swift. Then we have tools, so list of the tools for creating an iOS app is with Xcode IDE, and an emulator as well. And lastly, for drinks caffeine, so false for instance, and maybe you're gonna have these two as well. I'm not gonna add them. And let's have println hi, I am Android dev, I write apps in Android dev dot languages. Gonna have another one, hi, I am iOS dev, I write apps in iOS dev dot languages. And if we run the program, we would have this here. So hi, I'm Android dev, I write apps in Java Kotlin. Hi, I'm an iOS dev, I write apps in Objective-C Swift. So that was it for inheritance video. In the following videos, we'll discuss more about classes like abstraction, numerous classes, interfaces, and so on. So thanks for watching, and please stay tuned for the next video.